Hello, physical science student. Mr. Worley here. We're rolling into lecture 5-2, ionic bonds. Our learning objectives are to identify the properties of ionic compounds. That's like, what are they like? Explain how the formulas and names of ionic compounds are written. How do we write them? And describe ions and explain how they form bonds. Well, how do they form? You have learning activity, page 163, 1 through 3, or you can choose that or the writing in science. If you choose the writing in science, please write 1 to 2 paragraphs. I want them to be complete and substantive. Substantive means not fluffy. Okay, make sure you have a pen, a pencil, a paper, your book, and a few minutes to go. Here we go. We're going to be reading today together ionic bonds. You and your friend walk past a market that sells 40-cent apples for 40 cents each and pears for 50 cents each. You have 45 cents and want an apple. Your friend also has 45 cents but wants a pear. You realize that if you give your friend a nickel, she will have 50 cents and can buy a pear. You will have 40 cents left to buy an apple. Transferring the nickel gets you both what you want. Your actions model, in a simple way, what can happen between atoms. Are you reading along with me? Are you following with your finger in the book like my pen is moving? Or, if nothing else, are you reading along the screen? Student, if you choose just to zone out and listen to the beauty of my voice, you're not going to learn anything. Please, read with me. Next page, page 159. Ions and ionic bonds. A little cartoon. When an atom loses one of its electrons, it becomes a positively charged ion. The atoms that gain the electrons become negatively charged. Here's a joke. I'm about to lose an electron. Are you sure? I'm positive. Ha 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 ha. You get it? He became positive because he lost an electron. Anyway, ions and ionic bonds. Atoms with 5, 6, or 7 valence electrons usually become more stable when this number increases to 8. Check the last video if you forgot what valence electrons are. Likewise, most atoms with 1, 2, or 3 valence electrons can lose electrons and become more stable. When these two types of atoms combine, electrons are transferred from one type of atom to another. The transfer makes both types of atoms more stable. How ions form. An ion is an atom or group of atoms that has an electric charge. When an atom loses an electron, it loses a negative charge and becomes a positive ion. When an atom gains an electron, it gains a negative charge and becomes a negative ion. Figure 8 lists some of the ions you will often see in this book. Use this table as a reference while you read this section. Oh, this looks like a good quiz question. How does an atom become an ion? Look at this vocab word. Totally cool. So in short, basically what is it saying? It's saying we've got an atom here, and its nucleus is positive, and around the edge we've got electrons that are negative. But if one of these electrons goes, then the total charge, let's see, the total charge will be what? Positive. Okay. Polyatomic ions. Notice in figure 8, some of the ions are made of several atoms. For example, the ammonium ion is made of nitrogen and hydrogen atoms. Ions are made of more than one atom called polyatomic ions. The prefix poly means many, and atomic means many atoms. You can think of a polyatomic ion as a group of atoms that reacts as a unit. Like other ions, polyatomic ions have an overall positive negative charge. Let's check out this chart. Lithium. Its ion is charged +1. The symbol is Li+. See a pattern? Here's ammonium, +1, NH4+. Whoa, look at that. That's a polyatomic ion, many atoms in one, acting as a team. Polyatomic. Check out that chart. What's a polyatomic ion? Good quiz question. Okay, moving right along. On page 158. Sorry, page 158. An ionic bonds. Now we're going to learn about the bonds. Look at figure 9. Oh, let's look at figure 9. See, it says formation, I'm going to zoom out. It says formation of an ionic bond. Reactions occur easily between metals in group 1 and nonmetals in group 17. Follow the process below to see how an ionic bond forms between a sodium atom and a chlorine atom. Why is sodium chloride electrically neutral? Okay, so here's sodium with its 1 valence electron. It gives it to chlorine, so chlorine now has 8 valence electrons and is negative, and sodium has sodium doesn't appear to have any valence electrons, and it's positive. The sodium atom becomes a sodium ion with a charge of 1. The chloride ion becomes a chloride ion with a negative 1. And guess what? They get together. Let's get together right now. The positive sodium ions and negative chloride ions attract each other. This attractive force is an ionic bond. Each sodium ion balances the charge of 1 chloride ion. So, overall, the compound is electrically neutral, and therefore it stays the same. Dude, this is salt. Check it out. Even though the atoms aren't technically holding hands, the charge is so strong that it keeps salt together. Nice. Unless it dissolves. Okay, isn't it amazing? Remember sodium metal, how it exploded in water when we put it in water? Chlorine gas will kill you in one breath, but when they trade electrons and get together right now, they become salt, something we need to live, and if we don't have, we sadly die. Okay, anyway, way cool. Let's keep reading. Because oppositely charged, look at figure 9 to see how sodium atoms and chloride atoms are combined to form sodium chloride table salt. Notice that sodium has 1 valence electron and chlorine has 7 valence electrons. When sodium's valence electron is transferred to chloride, both atoms become ions. The sodium atom becomes a positive ion, so Na+. The chloride atom becomes a negative ion. Oh, wow. Because oppositely charged particles attract, the positive ion, sodium, and the negative chloride ion attract each other. An ionic bond is the attraction between 2 oppositely charged ions. Ionic bonds, vocab word, da-da, good quiz question. Ionic bonds form as a result of the attraction between positive and negative ions. A compound that consists of positive and negative ions, such as sodium chloride, is called an ionic compound. Okay, let's go to our next page. Chemical formulas and names. Here we are. Chemical formulas and names. Let's zoom in a little bit here. All right. Compounds can be represented by chemical formulas. A chemical formula, vocab word, is a combination of symbols that show the ratio of elements in a compound. For example, the formula for magnesium chloride is MgCl2, Cl little 2. What does the formula tell you? Formulas of ionic compounds. Oh, this is a great thing to start a new section in your notes. Maybe just underline it or write it in big letters, and so that way you can go ahead and write down underneath what the points are. Take a minute and do that. Put me on pause. From figure 8, you know that the charge on the magnesium ion is 2+. When the ionic compounds form, the ions come together in a way that balances out the charges of the ions. The chemical formula for the compound reflects this balance. 2 chloride ions, each with a charge of -1, will balance the charge of the magnesium ion. That's why the formula magnesium chloride is MgCl2. The number 2 is a subscript. A subscript, vocab word, a subscript tells you the ratio of elements in the compound. For magnesium chloride, the ratio of magnesium ions to chloride ions is 1 to 2. That means there's 1 magnesium for every 2 chloride. Okay, that means it's time to move on. Go to the next video.